Good morning, one and all. Myself, Dr. Anjali Gupta, and I welcome you all and our eminent speaker, Dr. A. Mukherjee, to second day, session 2 of Atal sponsored 5 days online FTP on contemporary advances in sustainable integrated infrastructure, organized by Department of Civil Engineering, Manavachna Institute of Research and Studies, Faridabad. 1 minute. We have completed our first session for the day and the participation from audience is really appreciating. I hope for coming sessions also all the participants will involve actively. This session is for 2 hours and our expert will speak for 1.5 hours and we will keep last 30 minutes for discussion and question answers. So let's begin our session energetically and I take the privilege to introduce our expert of this session, Dr. A. Mukherjee. Dear participants, Dr. Mukherjee is currently working as a professor and HOD, Department of Earth Science and Environment, MRIIRS. He did his PhD in sedimentary geochemistry and MSc in geology. He has 4 years of experience as practicing hydrogeologist in Government of Indian Central Government Water Board and Upper Yamuna River Board, Ministry of Water Resources, including 5 years experience as a faculty member in National Training Institute of Groundwater of Central Groundwater Board. His current areas of interest are hydrological investigation in karst aquifer terrain, planning, design, and site selection of water wells for industrial and community water supply, rainwater harvesting, artificial recharge of groundwater, watershed and springshed development, urban hydrogeology, study of geogenic contamination of groundwater, especially sulfate and arsenic. With this brief introduction, I request sir to take over the platform. Over to you, sir.
Thanks a lot, Madam Anjali, and I thank the Department of Civil Engineering under Faculty of Engineering and Technology, Manav Rachna International Institute of Research and Studies, for giving me this opportunity to interact with my friends all over the India. I also thank Professor Sunita Bansal, HOD, Civil Engineering, to be considering me as a guest faculty for this prestigious FDP of AICTE. So, good morning to all dear participants, my friends and colleagues. Today, I am going to give you a short of snapshot about the GIS in civil engineering infrastructure. As you people are knowing that GIS is nowadays growing a very rapid speed. Earlier, we call it GIS, but the new terminology is Web GIS. So the internet and GIS has clubbed together and the domain of GIS has increased a lot. So I am not a GIS expert, but what I do lot of use of GIS for my various research problem, solving the research problems and decision making in various aspects of my research and academic session. I have worked for 24 years in Central Groundwater Board as a groundwater specialist. There we use GIS for creation of various kind of maps. In last 4 years in Manav Rachna, I am also using GIS for solving various problems of groundwater and water related aspects, which also include many of the civil engineering infrastructure. So I think I should share my experience in GIS application in civil engineering infrastructure so that people who joined this FDP from various corner of India, they can also have a advantage taking my experience in their own field. And also there must be some people who are already using the GIS. They can have a new direction to see how GIS can be applied in various domain of engineering, particularly in civil engineering. GIS application in day-to-day life, if you see, you can find that Apple, Uber, Amazon, LinkedIn, Facebook, Microsoft, Ola, Twitter, so on, various Flipkart, and many more companies wondering what is the connect in these word. The connect is the location. So all these companies or business tycoons, they are using the location and how the location is available to us in this domain, that is through GIS. So geospatial expert of global leader says that location has always been vital to making sense of the dynamic world around us, and geography according to study of spatial relationship between component of the world. So these kind of notations are coming from the global leaders. You people see that we always use nowadays various GIS based software like Google Map. We all are using now. Uber, Ola, almost everybody in, even in small township, not even only the metro, all the small township area, people are using Uber, Ola. Then train running status, we are very much informed about our railway and when the train will arrive at particular our station, where presently where it is, so that we can guess how much right time it is running, whether it is running on time, whether it will reach our station right time or not. Even for food, etc., we are using Zomato. These all software-based industry, they are using GIS. Now, coming to particularly the GIS application commonly used in civil engineering aspect. So what we do in civil engineering aspect, for construction of any civil engineering infrastructure, we need location. Precise location is required, and look surrounding area what we are having, those kind of thing we can have from map, and precise location through coordinate, which you can be very well take off from the GIS map. If you are moving around constructing a road, so road lining, what will be the layout, what is, where will the culvert will be there, bridges, if tunnels are there, if you want to make flyover. So if all the site selection for these particular road and road related construction, and GIS is very, very much useful. Seeing the railway, how railway track, new track, where from we have to lay out the new track so that it should be most economical, so that less number of bridges and tunnels should be required. So to identify, the preliminary survey are always based on the remote sensing and GIS based. Then where to make a bypass, yeah, where to make a underpass, these kind of thing. Underpass is required in to cross the railway track this way to that way. So, but The main problem comes in the underpass area, as you can see in and around you, that the underpass area is filled with water in the monsoon season. So the site selection for underpass in the railway track can be very, very important, and you can minimize the water logging through the application of GIS. Similarly, if you want to make buildings, whether it is a domestic, commercial, or industrial, you can make this kind of site selection where the domestic buildings, where the commercial building, where about the industrial building can be made. Urban planning is one of the main area of civil engineering, where we can make the drainage, water and sewer lines, then transmission line for power, gas, telecommunication. All these required, particularly the area where from we can connect our lines, from which area we should lay the line, what is the geology. If we can and know the geology, we can know the, we can avoid the cutting of hard rock, so that our particular project should be cost effective. Similarly, irrigation. Irrigation is a major sector in civil engineering, where we have to lay canals, we have to make dam, reservoir, AICTE. They are laying track, their site selection are mainly associated, decision making systems are associated with GIS and remote sensing. Similarly, one of the important aspect of civil engineering is environmental assessment, impact assessment, how, where our particular industry or particular site is there, infrastructure site, what is the surrounding, what will be the impact, what will be our rainfall, what will be our geology, what will be our forest cover, if there is any national park or heritage site or like that. Particularly, we are having this kind of things in and around for impact assessment. Decision making, decision making for this kind of thing are very important. Say seepage around the basement, water logging in particular area. These kind of decision making we can make by use of GIS. We can see the examples. Disaster management, particularly flood and landslide. These particular two, disaster management in civil engineering construction, very much been helpful through GIS. So what actually GIS do? How we do the GIS, what GIS mean? GIS means your geographical information system. So what geographical information system is, why it is important? Any structure, any earth you can make on earth's surface or beyond the underground structure in the earth, you need first to locate yourself on the map, and then you need various other layers that we know as thematic layer, which can be superimposed on that particular area. So GIS is a integration of various thematic layer on a, for a particular site. Once you know the thematic layer which are available to you for your decision making, then you can superimpose those layers on each another. You can shift those layers according to your priority. You can give which particular layer has more weightage for your construction. Say you want to make a foundation for civil engineering, heavy civil engineering structure, then your geology and hydrogeological aspect of that area should given as the more weightage. So this kind of thing, your topographic area should be given more significance or weightage. Demography, land cover, land use, other layer of imagery, these also be uh, taken into consideration, but according to your project, you can change their weightage. So GIS application makes the from reality to either raster or vector image. So what is the difference between a raster and vector image? The raster images are like our bitmap. What is bitmap? Bitmap, as you know, you are using in Microsoft Office the Power Paint. Paint is a software where if you draw anything, the each line or point takes a pixel. So the extension will be your uh, these kind of maps are bitmaps, and once you enlarge those bitmaps through GIS, then it will, after some course of zoom in, you will find that the pixels are there is a distortion in the pixel because it is started blurring. But once you convert the raster map into vector map, then whatever zoom in you do, whatever type of zooming you can come, but that particular line or point or polygon, it will never be blur, or it will remain in that shape. So that are the vectors are the path and raster are the bitmap. So making vector is give you a added advantage. It will reduce your data, but vector images are more costlier than raster image. So raster to vector conversion is one of the aspect of GIS, where GIS from GIS to if you take output of GIS map through your computer printer, or if you want to see through any other aspect, take printout through plotter, then you have to convert the vector map to raster map. And that's why if you enlarge it large enough, the pixels start blurring. So if you use GIS software and take printout directly from GIS software, then you have the facility that you can do the enlargement of your required quantity, and there will no blurring of the things. So what are the most important and commonly used software for GIS? So there are many paid and open source software. Most commonly used software includes ArcGIS, MapInfo, Google Earth. Then other software of open source are most commonly used open source software are QGIS. These software, QGIS is available free of cost to download. You can download this software, and it is not very tough to learn this software. With the YouTube demonstration, you can very well learn this primitive application of QGIS. And once you start doing some of your exercise, particularly on the GIS, then slowly and slowly you can pick up. And once you start with this kind of application, then you can plot. You can plot a point, you can plot a line, you can plot a polygon, you can superimpose various thematic layers, you can subtract or add two layers and their layer data. You can calculate or know particular thing of calculation of area or calculation of water or so on. And you can geo-reference your particular site. You can register a map which don't have any coordinate, but if you are having similar areas map with registered one, then even unregistered map you can register on GIS. The presentation of GIS output are excellent. You can use it for your presentation whenever you present a document before any meeting or anywhere before your client or for your academic purpose. GIS outputs are excellent for presentation. Real-time monitoring is one of the major issue of the advantage of GIS, and where we can do real-time monitoring of particular thing. As you know, our Google Map, where you can do the real-time monitoring, how your vehicles are traveling, particularly see Zomato. Once the Zomato, that boy starts from, delivery boy starts from the Zomato shop and reaches to your destination, in between you can real time track their location, where it is, how far he came, or how much time is required to reach your destination. Tracking and tracing, you all know that the particularly our COVID period, we are using that software. This software where we can have excuse me. Good morning. হ্যাঁ দাদা ভালো কটার সময়? একটা তো আমার একটা ইয়ে চলছে, এফডিপি চলছে, দুটো নাগাদ। হ্যাঁ 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 আচ্ছা, তুমি একটু বলে দাও, আমার এফডিপি চলছে। হ্যাঁ ওকে হুম Sorry, I have a important call, so I have to take that. So now, if we can see the various domain, I'm talking about the real-time tracking. Arogya Setu app is tracing and tracking can be used through Arogya Setu app. We have all used this particular app, Arogya Setu, during the COVID time. Now there are various domains where we can and particularly see the use of GIS, particularly land use management, network analysis, incident mapping, spatial measurement, then corridor selection, transport modeling, then logistic routing, then your topographic analysis, demographic analysis, engineering design, site selection, watershed analysis, resource investigation. All these domain you can use the GIS, and all these domain also required civil engineering requirement. So these are very important aspect. So one by one, if we see, we can take a example of particular locating yourself and what are the advantage of location of that particular. So you want to investigate or do some work in a particular site. So before you start that particular work in a site, to make your thing understandable, where the site is located, in the India map, in the state map, in the district map, and then particularly that particular site, what is their coordinate. All this kind of information you can take from the advantage of GIS, and you can present that in a very concise manner, what is shown in this slide. And this slide is self-explanatory. If you present this slide, anybody can understand which area where you are working. So no need of explaining anything more. Similarly, say you want to have a map. Since I am having a geological background, hydrogeological background, I am taking example from geology, hydrogeology, but you can take this kind of example from any field. So there are in India Gondwana formation, coal-bearing Gondwana formation are there. Now, if you see this map of Gondwana formation, you can see this particular map where my cursor is there. These are laying in a 1, 2, 3, and 4 particular track. But in which state it is coming, what are their distribution? If you just superimpose a straight map on that, you can very well say how much portion of Gondwana land is coming in Chhattisgarh, how much portion is coming in Maharashtra, how much portion is coming in Jharkhand, how much portion is coming in Andhra Pradesh, and so on. So, and even further, if you put district maps on that, block maps on that, then you can even locate your mine, particular mine, or any particular site where you want to construct any infrastructure. That particular mine or particular site is you can locate in your district, block, state, and region. This kind of thing you can very well do. Take an example of geological map. There are geological map available for the entire country. And if you want to construct a civil engineering infrastructure, you need to know the geology, but you don't know what is the geology just below the site you are having. So put on your location coordinate in this map, and that you can very well know what will be the geology of that particular area. So take an example of this particular point. Here we can see we are having limestone. If you go there, you will have a shale. So this kind of information based on the map is available. You put your coordinate and you can know your geology beneath the surface with the available information in the literature or available information with the various organizations. So this kind of very, very precise information for decision making can be done with the GIS application, which you can see very well. Another aspect of doing this kind of analysis is your land use. Say you are working on a factory area, which is having a geographical area of 80,000 square meter. Now you want to know how much area of your particular factory area or industrial area covered with working shade, how much area is covered with green area, how much is paved area, how much is your STP or rooftop area, quarter, etc. This kind of information you can gather, then you can analyze, and this kind of information is useful for your water resource planning of that area. Similarly, you can compare this kind of land use information for two different sessions, say two different years. I have taken an example of an area which is about 78 square kilometer. Of same area, we can compare for March 2010 with March 2020. Then if you see the change in land use pattern, then you can very well understand what is happening in this area. Say, compare the built up area. Built up area in this particular area is 2 square kilometer or 2.5 square kilometer around March 2010. But in the 2020 March, it is became 19.5 square kilometer. So there is a drastic change or increase in the built up area. Similarly, if you see, compare the water body. Water body is around 1 square kilometer in 2010, but that has totally vanished up from this area. So now you can understand what is happening in this area. So what to do for decision making as a planner, as a civil engineer, where to construct, which area to construct, what happening to water bodies, what happening to the forest cover. The forest cover has reduced from 23 square kilometer to only 5 square kilometer. So this kind of thing if happening, you can very well compare and take decision according to your requirement for GIS based application. Similarly, one of the very important aspect is the slope or elevation. So you know that digital elevation mapping is a very handy tool for any civil engineer. He can very well locate his site based on the digital elevation map, where the low-lying area you want to make, which are the low-lying area, which are the highland area, where the problem of waterlogging can come. This kind of decision, what is the slope, how much slope is there, if you want to construct a road, what is the slope, this kind of information you can have with the application of remote sensing and GIS. Earlier we are having Topo Sheet. You know Topo Sheet, na? Topo Sheet are those basic sheet which has been prepared by Survey of India for India right from 1850s. Survey of India is one of the Government of India's oldest organization preparing Topo Sheet. Topo Sheet feature all topographic feature of that area of a with coordinates. So before GIS, when we don't have GIS software or things with us, the Survey of India sheets are very handy for any geologist or civil engineer to do their analysis. But now we are having the remote sensing GIS and tool with us. So with the help of Survey of India Topo Sheet map, we can delineate the watershed very precisely and then transfer on the image of Google image. Say Google image, we can take a Google image for that, and we can plot our Google image, the Survey of India's delineated watershed, transfer to Google Sheet, Google Map, so that we can use that Google Map for our decision making. Similarly, the Google Map can be used for various other purpose. I will show you the use of Google Map in the subsequent our demonstration. But let me give you an example. See, this is a upper one is a Google image. All these are Google image of same area. Then along these lines, if we put a, if you want to know the profile, you can know the profile along this, how elevation, surface elevation varies. If you want to construct anything in between two hills, then your consideration will be different. If you want to put your any particular structure, infrastructure on the plan land, then your consideration will be different. So these kind of information decision support system you can have using the simple Google Map. And these are very simple. I will show you how to do. Many of you might be knowing all these things, but since we are a heterogeneous group, so we have to take all together. So we want to share this information for the new learners also. So along these lines, you can take profile, horizontal line, vertical line, crisscross line, and you can have the profile immediately, instantly on the Google Map. Another thing to compare your urbanization or habitation. How habitation of an area changes. Civil engineer has to plan the things according to the change in population, change in habitation, density of the population in a particular area. I am taking an example of a small area known as Maneshar, nearby village Kho. In 2002, you can see how the urbanization in that particular watershed area, and what happened to 2010 and what happened to 2018. So see the change in the population of the within the watershed area. This portion, the upper hilly region, remain the same, but the low-lying, the plain area, the density of population has increased from 2010 to 2018, 100%. See the density of the population, see the density of the constructed house. So once these constructed houses were constructed, then the paving of that area has totally altered the land use pattern. And due to this change in land use pattern, there are so many civil engineering problems exist. Now, if you want to do a sewage line, you can plan here with this population, but within a span of 16 years, the entire thing changed like this. Then you're planning with 2002, this much of populated area cannot be very sufficient for 2018. So this kind of change in population, now 2002 to 2010, you can see the change in pattern. Now the township is expanding horizontally along the foothill. So any infrastructure you need, you have to plan in this area, and how to draw the sewage line, how to construct the drainage system, how to construct your water supply thing. All you have to plan in the seeing the trend of the urbanization in this particular area. And you can know this hilly area is beyond the reach of the habitation. So you have to plan the here and subsequently in the downstream direction. So any field information you can collect from field using your GPS. GPS is your global positioning system. Handheld GPS are nowadays available very easily in very cheaper cost. Within 25,000 you can have good handheld GPS. That mobile smartphone technology has even reduced the cost of taking GPS reading. Many of our smartphone is now having with GPS location uh, enable. So you can take GPS reading through your mobile phone or handheld GPS, then of a particular area, and you can transfer all those points to a map. And with this, you can classify those points based on their uses. Say, I have plotted here pond with water with this mark, but similarly pond, dry pond, we have plotted in this shape. So this kind of, you can make your own classification and then put on a map, superimpose on a map, and you can have your field-based data converted to map, and interpretation will be very, very useful for this kind of location. Say, I am having dry dug wells, all dry dug wells, and I am having abundant dug wells, and then I am having running tube wells. So you can see my dry dug wells are mostly laying in this area, whereas my running wells are mostly situated in this area. So you can interpret through that key what happening here, why the wells are going more dry in this area, why the wells are going more dry in this area in comparison to this area, why there is a patch here where our wells are going dry. So our water system supply of water from surface water or outsource water should be more in this area. As for planning of civil engineering, we should more concerned about this area than this area. Here people can have their own well still running. Here also they are having wells still running, but these area the wells are gone dry. So we need the civil engineering amenities in this area in near future for sustainable development. Then one another thing, take the electrical conductivity of particular area. Where are the groundwater is fresh, where the groundwater are saline. So you can map all those things. Then your amenities along with the drainage pattern, natural drainage pattern, where is the natural drainage pattern and what are the impact of natural drainage pattern on the civil engineering, that all you know. Now you have to classify your structure, you have to plan according to, say you want to make a road of this small township, then you have to take the consideration of these natural drainage. Once you know the GIS, through GIS map, where is your road and these natural drainage, then taking a road in this particular section is costly than taking a road from this. Here you have to only travel through one drainage, but if you take a road like this, you have to cross some 7-8 drainage. So cost wise, construction of road is always safer or cost effective in this area, and safer also. This area, due to drainage, you may have some flooding, etc., but here you will have less chances of that. So this kind of decision making you can do. Similarly, water resource is one of the calculation of water resource is one of the major area of civil engineering, where we do the hydrological calculations, and hydrology is part of civil engineering. Water resource is nowadays water, whether it is a fresh water or wastewater, both are equally important in our society. And calculation of these water, how much water a area can produce, is one of the major challenge in civil engineering aspect. So based on the GIS map, you can classify your area, say that same Co village or Manesar, we can classify hilly area 100 square, 100 hectare meter and 100 hectare, then open land in 60 hectare, and built up area is 40 hectare. To total co area, we are having 200 hectare land. Normal rainfall of that area is around 600 millimeter, and hilly area will be a average catchment area, open area will be a bad catchment area, and built up area will be a good catchment area. As you know, this classification we can have from strange table. So this, using this strange table, we can classify this area, then how much water we can have from this area, total precipitation into area. This is the area and this is the total precipitation. So we will have this much hectare meter of water. But how much runoff can be generated from this area? We can calculate the runoff generation from this area. Total runoff can be generated 17.9 hectare meter, and the potential of utilizable runoff is around 4.5 hectare meter, taking a 25% of effective runoff of this area. So this kind of information you can very well see from the given GIS application. Then plotting of field data on map. If you construct if you design if you survey any field data on a particular field, that you can transfer on GIS map or even in the Google Earth map or Google Earth image, so that you can decide with what to do with your field data. I'm taking a small example. As you have seen the Co village, there are two particular area. One is the highland area and another is a downstream area. Consider two time period. One is 2002, another is 2018. So in 2018, this particular pond, you can see the water here, but during the 2002, this particular pond area is totally dry. So due to urbanization, this dry pond of 2002 become a water full pond in 2018. Similarly, there is another pond in 2006. It is a filled pond. You can see here water is visible, and 2018 that pond is dry. So urbanization or civilization in particular area can make your pond dry. At the same time, in other place, it can make your pond filled with water. Why it is happening? If you see the GIS map, this particular area is the downstream area, and all the water from this civilization, the sewage is running towards this pond. And so the sewage water filled in this area, that dry pond of 2002 become a wet pond in 2018, because in 2002 there is hardly any population, so any sewage water is not receiving to this area. But in 2018, lot of sewage water is receiving to this pond, so this pond become totally water filled. But in 2006, this pond area receiving the runoff, but due to the over exploitation in the downstream, this pond area became dry. So you can see the picture of this pond here. And similarly, you can see the dry bed of this pond uh, below. Now, what happened? If you see the distance between this hilly area and this low pond, it is almost 860 meter, and the elevation difference is 53 meter. This you can very well understand through the GIS map. Just you put this profiling, you will get the distance and elevation. How to do that? I will show you. Then if you put water bring from this area to this area and let it go down in the lower slope area. Lower slope area is, if you put water here, the downstream side is this area, 38 meter if it run, it will fall some, if it is run for some 450 meter, it will have a fall of 38 meter. So natural falling will give you a aeration and purification. So that is this is a map of a flow map, how we can take this water to the grid system and settling tank, then through your constructed wetland, how we can bring it on the hilltop, and again through this and make our area recharge. So this kind of a micro level planning can be done for a particular village area where you have a study using your GIS. Similarly, enhancement of biodiversity. Nowadays, civil engineers are more concerned about the environment. Green building, green environment are more important. So you are more concerned about the biodiversity around you. So where you have to put, which are the area where your biodiversity can grow very well with a little effort, that you can know from this biodiversity map using the GIS application. Take another example of a small village or urban pond. This watershed area is having this pond, and this pond area, if you can see with a Google image, and then if you do your topographic survey, civil engineering survey, then you can plot this entire area like this. Then you can calculate in and around that particular area, what is your pond area, how much is your roof area, what is your green area, and that through this, what is your that area's rainfall pattern, and based on their rainfall pattern and your this land use pattern, you can calculate the runoff potential for this particular urban village, which is receiving sewage also. So you can calculate this kind of thing to restore a pond. As a civil engineer, you can restore a urban area pond using the GIS decision-making system. Barkhal is a famous lake in and around Delhi NCR, located Faridabad, but it has gone dry. How it has gone dry? What is their chronology? You can see the chronology from 2002 to 2010. How the water level has changed in the Barkha Lake. See, the rainfall is given along with the year. So 2010, 2002 to 2010, how water has slowly disappeared on the Barkha Lake, there on the bed. You can see here it is very well visible, the water. Here also the water is visible. 2004 also visible. 2006 it is little bit there, but 2008 onwards, total water has gone dry. Similarly, taking another example, a case study of an area where arsenic problem is there in Chhattisgarh area. So if you have the geological map and you are having the field data with you, then you can say which part of the area is giving more arsenic. So now you can correlate your arsenic concentration with the geology, and you can see here in this particular study, we have seen that the basic dike area are less contaminated with arsenic than the acidic rock of granite and rhyolite. So we have avoided this acidic rock and taken the basic dike for giving a safe drinking water in this area using the GIS application. So Google Earth exercise, we can see a Google Earth exercise. Before we start a Google Earth exercise on the Google Earth, let me put this case study in front of you. The DMRC has constructed metro in Delhi. So during monsoon 2020, there is an incidence of seepage of water is reported in basement of M, S, and E block areas of GK2. GK2 is Greater Kailash. Greater Kailash pocket of New Delhi has started reporting, resident of Greater Kailash started reporting that they are getting seepage in their basement. And they alleged DMRC that it has been concluded that this is due to the newly constructed GK2 metro station and laying of underground diaphragm wall and metro track in that area. So this is a very serious allegation against DMRC, and DMRC as a public organization, they are concerned about the public interest. So they have started engaged us for fact finding. So there are some facts they have produced, and we have collected some facts that the said metro construction was completed in 2015 and 16. And the long-term rainfall in that area of Delhi particular, if meter rainfall occurred during that year against the normal annual rainfall of 600 to 800 millimeter, means 0.6 to 0.8 meter. Normal rainfall in Delhi area at particularly GK2 is 600 to 800 millimeter, but in the year 2020 there is a excessive rainfall of 1473 millimeter, and GK2 is situated along a 3-kilometer long quartzite ridge. Just side foothill of that, the area is densely populated, and the land cover and land use of the area is heavily altered due to intense civil construction activity, high-raised apartment, and all other civil engineering construction. The real-time groundwater level data of the area obtained from nearest monitoring station established in 2019 at Astha Kunj, New Delhi. The real-time data of the area shows that the area is having water level raised beyond 300, shallower than 3 meter, only for 3 months. Remaining all the time, the groundwater level is below 5 meter in the entire area. The groundwater flow direction has been determined for the area that the flow is toward northwest and along the ridge. Ridge being a quartzite ridge cannot allow groundwater to cross along. Similarly, when DMRC constructed the metro station and diaphragm wall, that also worked as groundwater barrier. But what we have seen that in such case, the accumulation of groundwater should started immediately south of the GK2 metro station. The nearest southern locality of GK2 metro station and underground metro track area is Savitri Cinema and its surrounding. And there are no, these areas are also densely populated, but no such complaint was received from Savitri Cinema and surrounding. All the complaints were received from M block and S block. That blocks are almost 1 kilometer to 1.5 kilometer away from the metro track. So it can be concluded that based on these facts, we can conclude that the alleged seepage in the basement are not due to the construction of metro line or metro station. Rather, it may be due to construction in the local area of the particular GK2 block of M and S. How we can see this? We can have this in the real-time picture also. Let me explain first in this picture. This, you can see this map. In this map, this darker zone are your ridge. These darker zone are your ridge, and these, the foothill area is your GK2 area. And GK2, the metro track was laid down along this track. Savitri Cinema is located here. GK2 metro station is located here, and our real-time monitoring station is located here, groundwater monitoring station, just above that road. And M block is situated something around 950 meter away from the track, and S block is situated again some 105 kilometer away from the metro track. The seepage is mostly reported from this area, but no seepage incidence is reported near the metro track. So if the groundwater flow is northwest, in northwest direction, then water accumulation, if occurs, then first affected area should be this area, nearby area. But that is not the case. So we are in the opinion that this incidence is probably due to some local activity in and around the M block. Now, see the real-time monitoring stations data of the groundwater level. If you see the groundwater level, the groundwater level available from 2019 August to 2021 July. See, this is red line is your 5 meter level. The water level in this area, entire area, remain below 5 meter almost entire season of 2 consecutive years. Only there is water level shallow than 5 meter only for some period, and water level shallower than 3 meter is only for 2 to 3 months only. So we concluded that this particular incidence is due to a local activity induced by the heavy rainfall in 2020, when there is a rainfall of more than 1400 millimeter in this Delhi area. Remaining period, when the rainfall is beyond less than 1000 millimeter, the groundwater level always remain below 5 meter, and when the groundwater level remain below 5 meter, there is no question of water logging in the basement, because the basements are largely 2, 3, 4 meter in depth. So there must be no incidence of seepage through basement during the maximum period. Now let me take you this another example, live example of this particular uh, exercise. I will stop sharing this and I will go to another Google Map. Is it visible to everybody, the Google Map? Anjali madam? Hello?
Yes, sir, visible.
Okay. So now if you see, we can make this Google Map first. Let it zoom out. If you zoom out this area, then you can see this is your Delhi area, this is your Noida area, this is your Faridabad area, and this is your Gurgaon area. And geologically, if you see, you can see a folded mountain is going around this. Folded mountain is there, and GK, and here you can see the Yamuna river is flowing in the eastern part. Now let us zoom in into the area, particularly GK2. So if you zoom in, this is your Yamuna and this is your ridge. So groundwater, major groundwater flow direction will be from ridge to towards the river. But local groundwater flow direction has been estimated parallel to this. Now parallel to this, this is the ridge. This ridge is made of quartzite, and this is hard rock, and this particular area where GK2 is mainly having their residence is all mostly of quaternary alluvial rock, followed by the hard rock below. But here the hard rocks are exposed here. So any groundwater cannot cross this natural barrier, or any groundwater from this area cannot move towards the GK2. So only groundwater of this area will be there. And if you see the construction of metro, if we put this road, so the construction of metro, now you see these are the station. This particular station is your GK2. This is your Chirag station, and so on. This way, if you go, you will get the Nehru ground, etc. So now if we have our all these particular area of our interest, the point of our interest in the map, now if you put one by one the various point of interest in the map, it will be projected like this. See, your Astha Park real-time groundwater monitoring station is situated here. And this is your GK2 station. This is your Savitri Cinema. This is your M block. This is your S block. This is your Greater Kailash area. Now, as you have seen, the metro line has laid down perpendicular to this ridge. So there is a natural barrier here along this area, and there is a natural barrier now constructed here due to the underground track of metro and construction of metro station and formation of diaphragm wall. So once, if you see, the metro underground construction is over by 2017, but there were no incidents of seepage during 2017 to 2019. If it is due to the obstructed flow of groundwater, the seepage problem might have started just immediately after the completion of the metro construction. In 2017, 18, 19, the seepage must be there in this area, in the underground and basement area. But there were no complaint of seepage through basement up to 2019. All of a sudden, the complaint started coming in 2020 due to heavy shower in 2020, almost double in the quantity. So due to this and there must be some local activity going on in this particular area of M block and S block, due to which this local activity has maybe blocked certain amount of flow, and during the heavy rainfall, the water level has momentarily for 2-3 months have gone up. So this kind of information you can have through your GIS application. Now, if you want to put there's any section of this particular map, you can construct a line here. Say, draw a line AAM. So if you draw a line here, crossing your ridge to taking up to your this location. Now you can save this line. Name is AAM on your Google Earth. You can do it on your Google Earth instantly. Now take this line and ask it to show your elevation profile. So see, this is the line where our cursor is there. We can start. This is the start of the line, and along the line, if we move, just once we move away from the hill, we are coming to plain land, and then there is a little bit hump-like structure. Then there is again very down. So you can see the particular elevation. So anything here between elevation 232 and 232 meter here and 239 meter here, in between this elevation, you can find a depression, and any water logging can happen in this very localized depression due to heavy rainfall. And this particular area is coming near to your M block. But similarly, if you see, if you go away from this area, this area, the elevation is low, but though there are diaphragm wall is constructed here or metro underground line is constructed here, but no waterlogging incidence is reported in this area. Now, if you want to delete this and you want to take another section across this area, say I take another section, line 1, 2, 3, and this line will move from this area to, sorry, so this area to this area along this line. So now just take ask to give you a profile along this line. What is happening here again? You see, you go to the beginning of the line. Beginning of the line is here. This is the elevated land. Then here it is another elevated land. Then once you pass away this, then there is a these all are elevated land. These all are, if all these are elevated land and the ultimate slope is this side, so any water logging due to this particular thing will occur first in this stretch. See, this stretch you will get water logging first, but that is not the case. You are getting water logging in this area. That is due to a very small depression created in this area, and that is maybe due to some local incidents happening in this area. So such kind of thing you can do with your GIS application, and this kind of your decision making with proper scientific background you can show to your client with all your scientific data. So I'll stop this Google Earth map now, and I will move to another exercise of map info. I think it is visible to everybody, the map info file.
Yes, sir, it's visible.
Okay. So map info is a GIS software where you can register your map either as a raster image or as a vector image. What is raster image? You take any picture and register it. That will work as a raster image. But anything you draw on with the help of GIS software, that will remain as your vector image. So say this is a map of India, and I have taken this map from somewhere, and I am using this as one of our layer as a raster image. So I have registered this map according to geographical location, all coordinate geo-referencing I have made, and I brought this as a raster map in the software. Now, if I start putting further subdivision of this particular EA, I have made further subdivision of that map with earlier it was, you can see now again compare. Earlier, just go back. Earlier it is like this. No finer details are available. Once you put another layer with a finer details of 43 aquifer, the map is looking like this. So you can have more detailed map. Now you have also added the state boundary along this. Now with this state boundary, if you want to add district boundary also, you can see now your district boundaries on this. Now go to this area. Huh? So you can see the district wise raster image is getting blur, because when we zoom it, the raster image will not keep their pixel as with this. But you can see these vector lines. Vector lines are not going blur, but the raster image is going blur when we zoom in. Now, within the district, you can see the finer details and you can have your decision support system. Where is limestone? Where is shale? Where is the sandstone? With the aquifer map. Now, if we want to put your coordinate on this. So coordinate, so 1 degree by 1 degree coordinate. For any area, you know 1 degree by 1 degree coordinate. Then you can even further subdivide your 1 degree by 1 degree coordinate into 15-minute by 15-minute coordinate. So these are the 15-minute by 15-minute coordinate. Now within your topo sheet area, or very within your, precisely within your area, you can locate what is the geology or aquifer available to you. So this is the power of GIS with available very simple and simply done technique. You can have this decision support system at your own convenient doorstep. So these two examples will give you the how much power you can generate with simple tools of using GIS. Map Info and Google Map. So with this, I will go back to my slide section. So map info demo is there, and with this I will complete my particularly my talk portion. Now I am happy to interact with the participant if they have some question to with this particular session.
Thank you so much, sir. Thank you very much for this informative lecture and teaching us GIS from scratch and sharing case studies. I can see a few questions in chat box.
Madam, can you read out, please?
Yes, sir. 1 minute, sir.
Because I'm able to see only few questions that is regarding the management aspect only of the session.
Participants, you can post your question in chat box or you can raise your hands.
Or even they can unmute and ask or verbally.
Yes, sir. The session is open for discussion now. Anyone who want to ask question?
So how can we import CAD drawings into this?
Ma'am, can you please repeat your?
I am not able to listen the question properly. क्या बोले?
Sir, can we import AutoCAD drawings into this?
Yes. We can include AutoCAD on web GIS technology is there. And in the second session, after post lunch, we are having that particular demonstration how AutoCAD can be brought to your GIS platform.
Sir, if you can also share some research areas related to civil engineering and GIS, GIS applications of in civil engineering with our participants.
Hmm.
Something like traffic engineering or otherwise you've watershed areas, you've shared all that. So in case some additional research areas can be shared with.
Why not? Why not, madam? I can explain you regarding the recharge area watershed map. If we go back to our presentation, I can show you a live example of your recharge area. Can you see my slide? Na?
Not yet, sir.
Okay. I'll re. I think it is visible now.
Yes, sir.
So just see this map. Taking a example, this is a map of a area having topo sheet, a watershed, and an image and drainage. So recharge area and discharge area. What is recharge area, discharge area for groundwater? Any area where groundwater is mainly going in through infiltration to the aquifer is known as recharge area, and the area where largely we extract water or natural discharge is there from aquifer, those area is known as discharge area. But nowadays, since the habitation has gone in all dimension, even in the hill, we are abstracting water. So we can abstract water from a recharge, natural recharge area, and even we can do recharge in a naturally discharge area. Say, this area particularly is a hill area. Here, you can see all the drainage are emerging from this hilly area and finally flowing out towards the area. You can see a water body here. That particular water body is a tank, irrigation tank. So all this area, and this is since a hard rock terrain, in between there is a soft rock terrain, so all the groundwater flows towards this. So you can say these area as a recharge area and this particular area as a discharge area naturally. Now due to habitation, people have started taking groundwater in the hilly terrain also. So there is a natural recharge area can be converted to discharge area also. I'm clear?
Yes, sir.
Okay, thank you. Anything else?
If you can give us in the chat box the various websites where we can get the digitized maps.
Now, see, there are so many websites where the available maps are there. One of the very important website in our country's context is Bhuvan. You can go to Bhuvan. There you can have digitized map available for various land use. Bhuvan is a site where you can get many kind of map. Then water Varis Ministry of Water Resources is having a site called WARIS. WARIS is another site where you can get various digitized map of water related things. So there are other so many sites, local sites available, but these two are broadly used site, Bhuvan and WARIS.
Thank you so much, sir.
Thanks a lot. Again, anybody else?
Anybody else?
I can see a question in chat box. Sir, this is from Mr. Anand. He is asking, is it possible to locate ongoing construction in different places using GIS?
बहुत अच्छा, बहुत very good question, and really I have forgotten to show this. Now I will show this. Hello. Hi, sir. তো উনি তো আসবেন বলেছিলেন আমাকে, কি অ্যাভেলেবল হলে? ওকে, হ্যাঁ আচ্ছা ঠিক আছে, ওকে, থ্যাংক ইউ. So I will show you again. I will stop sharing this and I will take this Google Earth as our shared document, and then I will show you live demonstration of that. Is it visible to all?
Yes, sir. Map is visible.
So now see, this is a particular this area where we are working now, GK2. You see, this is GK2. Now there is a feature in the Google Earth where you can able to see the live constructions. Say, just let me focus on the GK2 metro station. We'll take an example of GK2 metro station. Just now, you please see, this is your GK2 metro station. Now, there is a feature known as this clock and reverse clock symbol is there in Google Earth. Show historical image. This icon is there. Once you click here, you will get this bar scale. There, if you go back, you will get older picture. Say now I have gone back to 2004. The month is April 2004. And if I see that particular area, GK2 metro station present locality, you can see there is no construction here during 2004. Huh? Now, slowly you move away. Huh? Now it is 2008. Still there is no construction. 2012, still there is no construction. 2015, see, there are so many construction. So between 2008 and 15, there are construction. So now we can fine tune it. You can again see in 2013 also there is no construction. Now, if you go back again, if you see now 2013, 2014, just you can see few initiation of constructions in this area. Then April the constructions are going on. It has come out in some amount. (2014), see, heavy machineries are there. You can see the shadow of those heavy machineries. 2015. Many construction has been there. So 2015 onwards, you can see now you bring anything, the constructions are going on, and then density of the construction along this has increased. And now we are seeing the map of May 2021. So by doing this, you can see the live construction, how it is going on in the GIS platform. I think this is very evident and everybody have enjoyed this. I can show you again. You see this area, particularly you see my this particular area. You can see this area. How much construction is going on? See, the construction is going on and how densely it has packed the constructions. So if you have map of past time, you can have the feel of the real-time construction through Google Earth.
So thank you, sir. Thank you so much. So myself, I have asked that question.
Okay, please.
So it was very useful. The session was very useful.
You have made a good question. Actually, I have to show this, but I have forgotten to show this.
Yeah, sir. Anyway, thank you so much.
Sir, I also have a question. Can
Please,
you
madam.
calculate the density? Is there any tool to calculate the density
Of what?
of the structures?
Why not? Why not? You take this polygon. You take this polygon and just digitize your map there.
Okay.
One. Then you take second, like third, fourth. So each area, say in 2015, how much density was there? In 2018, how density has varied? In 2021, what is now density? You can calculate.
Okay, sir. Thank you. Okay.
Remember that I'm going, I will show you that particular another location in this demo. I'll show you here the density calculation. Please recall my previous slides. I have shown you that in 2002 there is no population there, almost negligible.
Yes, sir.
See, now you just calculate the density around this particular area. And now slowly you go ahead. Year by year, you make your density map. Then just plot it through digitizing. Another thing we can do, pond area, how pond water is reducing. We can calculate year after year. And then we can plot a map and show how much water resource has gone.
That's
Is it
quite
clear, madam?
interesting part in this software. Thank you so much, sir.
Here, without any investment, without any tool, without any software, you can do all these things with the help of Google Earth. Just learning with the Google Map, just little bit learning of Google Earth use.
Yes, sir.
In last, say, 10 years, we have this tool, Google Earth. And it has modified the entire analytical system like anything.
Yes, sir.
So thank you very much. If any more question.
Participants, anyone? I think no more questions now.
सर मैडम दो चीज हो सकता है.
हाँ जी सर.
एक तो लोगों को इतना अच्छे से समझ में आ गया, देयर इज नो क्वेश्चन. या फिर एक दूसरा चीज भी हो सकता है कि सेशन इतना बोरिंग था कि पीपल डोंट वांट फर्दर टू बी देयर.
नहीं सर, हम फर्स्ट कैटेगरी में हैं. सेशन वाज वेरी इंटरेस्टिंग और बहुत सारा हम लोगों ने सीखा और आगे भी हम आपको डिस्टर्ब करते रहेंगे सीखने के लिए.
थैंक्स अ लॉट मैडम,
कैटेगरी
थैंक टू डिपार्टमेंट ऑफ सिविल इंजीनियरिंग calling me for this particular prestigious AICTE FDP program, and I thank all the participants for patience hearing, and particular thanks to those who have raised their question and given me opportunity for further explaining the things. Thank you very much.
Thank you so much, sir. Now I would request
I can show you my mail ID, and if somebody is interested to post me anywhere, I am ready with answers further. I have this is my mail ID and mobile number. Anybody have any question afterwards, they can ask me.
I have posted sir email ID in chat box also. You can copy from chat box also.
So thank you very much, madam. I think I have not taken much time.
No, sir, it's on time. Now I would request our HOD, ma'am, Dr. Sunita Bansal, for vote of thanks.
Thank you, Anjali. डॉक्टर मुखर्जी, थैंक यू तो हमें करना है. सारे थैंक्स आप कर देंगे तो हम लोग क्या करेंगे. Thanks to you, sir. Thanks a ton for such a comprehensive presentation. You've talked it all. सब कुछ आपने शुरू से लास्ट तक बता दिया. और GIS in civil engineering, it holds so much of importance and towards mechanical practice of construction industry. And you've shown it all. Sir, thank you so much. And I hope that we all, with our participants, would definitely try this tool and then, identify the dominant locations to conduct all that longitudinal analysis, and then come up with solution systems, maybe traffic engineering or infrastructure management, or maybe security solutions. Because when you were showing the construction, this thing, the first thing that came to my mind is that we can also identify the Pakistan occupied territories also at the border. So, that was one thing which was coming to my mind.
Nowadays GIS is being used for forensic.
Yes, forensic also. Okay.
Yes.
processing tools. That's great, sir. Thank you so
So
much, sir, for taking
thank you,
out
madam. Thanks a lot
time, sir. Thank you
for
so
giving
much.
the opportunity. Thanks.
Just we all love the presentation, sir, and you more than justified the aim of our FDP of addressing contemporary computational skills. Thank you so much, sir.
Okay, madam.
Dear participants, now we will meet at 2:30 p.m. on same link for the next session by Ms. Madiha Khan. It will be a practical session on GIS in civil engineering infrastructure. Thank you so much. Thank you, everyone. I have posted link in chat box. You can fill the feedback.